Good afternoon, everyone. Welcome to Engineering the Future, a SED Talks event organized in collaboration with the Saratoga Youth Commission and the Saratoga Library Teen Advisory Board. Before we begin, I just want to let everybody know, as you can see, there's refreshments over there, and in the back, please make sure to get a raffle ticket for the prizes behind me. And bathrooms out the door to the right.
Okay, so the TAB members who play a role in this event are Manlin Zhang and Ashwin Belur, our co-presidents, and TAB members Danish Ikolu, Tane Ubail, Avi Taneja, Arthur Gabrilovich, and Trisha Sanapanuvar. Sorry if I mispronounced that.
All right, everyone, and the youth commissioners here today are myself, Arjun Krishna, Justin Chow, our chair, and Brian Zhao.
Okay, so Engineering the Future is the latest edition of our annual SED Talks and is a speaker series that touches upon topics and issues local to Saratoga, from robots performing microsurgery to optical defense technology. Changing the world through technology has never been more promising. And in today's event, we have invited 3 speakers who have made exceptional contributions to these fields of medical technology, surgical robotics, and defense and education.
Before we begin introducing our first speaker, I'd like to formally invite the Mayor of Saratoga, Yan Zhao, to provide us with their opening remarks.
All right. Can you all hear me? Yeah. Good afternoon, everyone. I'm Yan Zhao, Mayor of City of Saratoga. It is my pleasure to welcome all of you to attend SED Talks, our Saratoga style of TED Talks. Today's theme is Engineering the Future. I know many of you here, maybe it's for the first time to come for the TED Talks, SED Talks. I'd like to first thank our Saratoga Library Teen Advisory Board and the Saratoga Youth Commission for organizing this event. Your dedication and hard work are truly appreciated. I also like to thank our speakers, and I want to thank you for taking your busy time off and to come here to share your experience, your knowledge, and your foresight in advancing studies with all of us. As an engineer working in the semiconductor industry for many years, I'd like to share with you my firsthand experience working in this field. I graduated from UC Berkeley in a bachelor degree in electrical engineering and computer science. My first job was an analog IC designer at National Semiconductor. Now it's part of a Texas Instrument, where I designed chips for laptops and other industrial applications. I was always very excited and proud of the work I did because I know the chips I designed help make a difference in people's life. So engineering plays a very, very vital role in shaping the world, from software development to IC designs to biomedical research, environmental and civil engineering. It involves creating, analyzing, testing new concepts, as well as new discoveries. So I'm so excited to see all of you here, and it's up to each and one of you to engineer your future. I am confident you all will make a big difference, achieve good things in the future. So enjoy the program, and thank you.
Thank you so much, Mayor Zhao. We appreciate your kind words.
It is my pleasure to introduce our first speaker, Dr. Sergio Gonzalez. Dr. Gonzalez is a family medicine and OBGYN physician at Kaiser Permanente. He serves as a clinical instructor for family medicine residency and for Boston University Medical School, of which he is an alum. Dr. Gonzalez is also an adjunct professor at Santa Clara University.
Please welcome Dr. Gonzalez.
Hi, everyone. Can you hear me? All right. I want to first off start with a little story. And if folks, you guys can help me hand this out and just pass them around. These are some things that I might talk about a little bit later as what we're doing in medicine nowadays. So how many of you guys have seen elephants? right? They tend to walk in a line, very calm animals. You know, you're like, wow, what powerful animals that can break down doors, walls, and run amok. But they start training them when they're very little animals with a rope. They keep that rope their life of training, and they learn to walk in a line and never fall out of line. I use this example to show that this amazing animal with immense ability to break down walls is limited by that rope, which they can break at any time, but since from their early days they are put to it on their ankles, they are bound. I want you guys to take and go above that and think you have no limits to yourselves, okay? Don't be bound by that rope. When your brain grows and becomes that big, powerful elephant, you can break down any barrier. And in STEM sciences, if you grow your brain that way, you can break down walls and go into any career you want. So I will talk about what I do as a family physician who also does OBGYN. I deliver babies and take care of them well into their hundreds if they live that long, and anything in between. So I can be involved in surgery and clinic care at any one time.
I heard this is not working, so we want you to try this.
Okay, let's try this. All right. Nope.
Go down.
No.
No?
No.
Of course, there's always a technical difficulty.
No problem. So do not be bound, okay? Don't be bound by someone telling you, no, you can't do this. If you put it in your head that you can do something, follow the course. Break out of that rope and don't be limited. That's what you want to do.
So you'll get a manual clicker.
Okay, I think there it goes. All right, so this is myself. Here we go. All right, so the future of medicine is bright, okay, guys? You guys know, you see a physician one-on-one nowadays, right? Maybe video. Have you guys done any video visits? Any of you? Yeah, right? That's a new thing, right? FaceTime, Zoom, you name it. Now you're communicating with your physician. We are moving to a wonderful future, okay? Medicine is going to change in my career and going to become more remote and more personalized because, as you see here, this young woman has decided not to get a vaccine, or let's just call it a medication. When she does that, all the bacteria, viruses, cancers, diseases in the world are now happy about that, right? So how do we protect that person? Technology is going to help us. Okay, there's 30,000 diseases in the world that we recognize now. 12,000 of them, or a fourth of them, do not have a cure. Okay, so we have a lot of work to do. And when I say do not be bound by the constraints of what's existing today, allow your mind to expand, because there are little things that you can do to solve problems later on, okay? And you'll see in a little bit. We're moving towards personalized medicine. Each of us now will have individual medications made for them in the future through genetics, nanotechnology, bioengineering, and all these things moving forward. I'm not an engineer, but I get the wealth of knowledge that is brought down by our scientists who are able to do this deep research and help me understand so that I can deliver that care to you guys later. So we usually look in medicine at prevention. Then we diagnose and we treat. So with improvement in technology, we're going to do this, okay? And as we go, please feel free to ask questions, and I will open up to questions. But this is kind of where we're going. So molecules can help us do diagnostics, medical imaging. Nanotherapeutics can help us in those regards. And vaccines are also things that we can make with all these areas of technology. Biomaterials, when we talk about biomaterials, if someone has a heart attack, that means part of their heart has died, okay, and it doesn't function anymore. How about if in the future we can take a cell, learn to control it, create a patch that can then be implanted into that heart? That would be a wonderful thing, right? If someone loses a limb, can we replace that limb with materials, engineering, robotics? All that stuff can help. There's multiple ways to an answer. So already start thinking. And for you young individuals in here, you guys are seeing the world in a different way. I had phone that had a cord. My kids see a phone with a cord, like, what is that? If I give them an old phone, they're trying to swipe through it, right? Because you're seeing technology in a different way. And that ability for you to see the world in that way allows you to have new ideas and implement them. But do not forget the past, because you learn from the past and build on the future. Okay, now another thing that's going on here is immunotherapy and DNA studies, right? What if I told you that 23andMe, who's heard of 23andMe, right? Has anyone ever done their ancestry? Maybe. Ancestry.com, 23andMe, all these are companies that are giving you that venue. However, they're patenting a lot of that sequences that they're studying, and they're learning things from them. We're going to use those sequences to bring treatment to you guys and give you personalized medicine in the future. So where one day, rather than give you a prescription for a medicine or go get lab work done, I'm going to go say, get some lab work done and let's do some DNA analysis and create an individualized medicine for you. At present, we know that medications for males and females do not work equally in them. There's a gender difference. We've got to adjust for that. We cannot render the same treatment that may not work for people. We know that individuals process medicines differently. So a very big individual may need only small amounts of a medicine. A very small individual may need a large amount of medicine. Size does not matter. So we got to adjust for that. So we will find ways to do this in the future. Genetics is a big way of doing it. So as you begin to see, I also want to have you pay attention. If you want to go into healthcare, if you want to go into STEM fields, there's a way you can work around healthcare through many means. And so if you do want to be involved, there's a big part of our team that we need someone at every level. As I was mentioning, stem cells. Has anyone ever heard that or understand exactly what a stem cell is? Yeah? What do you think a stem cell is?
Stem cell is a cell that has the potential to become other cells.
Exactly. It can do anything it wants, right? And you catch it early on. It can be gotten from the bone marrow or your cord blood. So when I deliver a baby, I have parents that ask me to preserve their children's stem cells or their cord blood, which are full of stem cells, and they're storing it right now. We don't know what to do with them just yet, but we are storing them with the potential of having cures later and learning how to use them. So there is that service for people nowadays. Should their child get in sick later, maybe we can use those stem cells within their lifetime. As we collect those stem cells, we can program them. We're coming up with a technology where we can maybe direct them to be bone, muscle, heart, what have you. And this is the goal of tomorrow, to use that technology today. Okay? So look at everything you can get it, right? Heart, muscle, diabetes, right? Diabetes is a problem with sugar processing. Can we do something to replace that? Can we have a little something inserted? Okay? Now, as we go that way, immunotherapy. Who's heard of the immune system? Yeah, it's what protects us, right? What happened in 2020, right? We all know we had to go indoors, right? COVID killed our ability to relate with folks. So we learned a lot of stuff, right? You guys, who got their COVID vaccine? Okay, you don't have to tell me actually, but it has protected us, and it was a great mobilization of a lot of scientists to bring forth this vaccine to help protect us all. COVID's still around and will be around for years. We're going to probably need COVID vaccine daily to improve our immune system, but that's taking our immune system a little bit of something so that our immune system recognizes it. And the technology behind that is great. CRISPR, DNA sequencing created all this. Reverse RNA or RNA sequencing went all into it. You guys beginning to look and understand that a little deeper will allow you to come up with bigger solutions. The immune system is complicated, and I just put this up here. At any one of these steps, you can intervene and create something. If you start with a stem cell, it can become any of these stuff. If you can control a killer T cell, you can control your immune system. If you can direct it to an area, then maybe you can get disease early on. And at any one of these steps, you can create a medication or an intervention that can cure. So if you can come up with that idea, you can be part of the solution. We're working on this still, and smarter minds than myself are working on this in the lab, in the engineering fields. So be ready for the future. Gene editing, exciting stuff that's happening. Gene editing is whereby you take a sequence and someone has a problem with it, you remove it, and you insert a new piece of DNA. Is that possible? Guess what? On the 18th of this month, Lenmeldi, a medication for metachromic leukodystrophy, a devastating disease that destroys the cover of your neurons. Any of you guys know what the cover of the neurons is called? For those, yeah? Myelin, great. So myelin is a little cushion that protects your nervous system and allows the transfer of information to go much faster so that we can make point-on-point decisions, right? Or pass on information to our muscles or our tissues. That gets destroyed. When that happens, you lose control of that body part. These kids do not make it past 5 years old, and they begin to have devastating deaths because of that. Lenmeldi was a gene-edited treatment that is now used as a drop, one-time treatment, and now, 12 years later, the first recipient is still doing well and has the enzyme that allows them to correct that defect. How amazing is that? Now, it comes at a price. It's $4.5 million for a treatment of Lenmeldi. Only 40 people in the world, typically in the world, get this, so it's a rare disease, so costs can be defrayed later, but the amount of studies that went in to create this medication is huge. But the future is amazing if we have this now. So again, we have a lot to do. CRISPR, has anyone heard of CRISPR? Yeah, right? Sickle cell disease may soon be a thing of the past. I think 20 years ago, we started treating a young woman, African-American young lady who got her sickle cell disease treated and now has normal coagulation for the most part because of that gene. It's a little machine that you now control and can direct to, it has a GPS device for DNA and allows you to read and correct errors. So once you take care of that, that's amazing. Okay. All right, now in the clinic, let me move a little towards the clinic. So what do we do nowadays? Back in the day, you used to go into the clinic, wait for an appointment, and be seen, right? If I needed an ultrasound, like, hey, let's take a look at your baby, or let's look at your heart, we would do it, send you to radiology, maybe in a week. Nowadays, this is how I do an ultrasound nowadays, okay? Thank goodness for the iPhone or whatever phone you have. And you can connect with this little device and I can get point-on-point ultrasounds on the spot. So if I see someone that comes into the clinic and I think they have a clot in their leg, I will put this on their leg, confirm that there's a clot, start treatment on the spot. If I see a baby maybe in trouble and I need to see their heart or see their some kind of function or what position that baby's in, I can make decisions, split decisions. So we're moving towards a great thing. Let me, I'll pass this on later. We can see it on our own. But how's this handheld thing that's in my pocket and I can take it anywhere, right? Pretty amazing. iPhone has also created little cameras to look in the ear. So if patients send me pictures of the ears, like Dr. Gonzalez, I've got ear pain and this is a picture of me. Oh, great, perfect. Here's the medication. This is what you're going to need, right? And so this is what we can do with technology, guys. We also have dermatoscopes, little cameras that can look at the skin, send us pictures, and we mobilize everything. If I don't know, I send it to my dermatologist, and you can get 10 doctors to see these images at the blink of an eye. So, who has the fetal scalp electrode? It should be a little electrode with a wire. Do you guys have of those? Oh, yeah, so go ahead and... okay. So this is a fetal scalp electrode. If you guys saw that, it's a wire with a little screw at the top of the head that actually goes into the baby's scalp. This allows us to directly hear or follow the baby's heart rate, and we can monitor that baby. Along with it is a second device that looks like a straw and it's also long. It's called an intrauterine pressure catheter. That catheter measures the pressure in the uterus and allows us to measure the contractions and see the baby's heart rate point on point. So we monitor these babies on the spot, which allows us to intervene if there's a problem with that baby immediately. And so if I need to deliver this baby via C-section, I know and I can make the appropriate decision, or if I feel that I can wait a little longer based on how the accuracy of the health of the baby, I have it. And this is what many of you guys that are here today probably had these devices or the ability to have these devices. These are more internalized. We have superficial devices that also do it, not quite as accurate, but these are the next level. How does engineering go into this? Creating these to be safe, the mechanics of transferring it to electrical signals that we're able to read and measure and quantify and be able to make medical decisions are important. I can never take back a baby being injured, but I can take back an injury to a patient that can be repaired, a muscle, a bone, I can repair that, but a baby's brain I can never take back, so it is of the utmost importance in birthing a child to know what's going on every step of the way. This is a device, it should be there, it's a balloon. After delivery, that does not stop the problems that can be encountered. The uterus may not contract or may continue to bleed, so it may need a little help with pressure. This cool device is pumped with water and inflates in the uterus, provides back pressure so that that uterus can have pressure, right? Have you guys ever been bleeding? What do? Put pressure. Same thing, but internally. Awesome device, great technology. There's a vacuum over there. There should be a little device with a pump, a little pink device over there, and pass it around because I want to. Should be no. There's a. Where is that vacuum? There should be that one. You can open that and pass it around. And I actually want people go ahead and open it, Mayor. Open it. It's a cup. Apply the cup to your hand and then pull that device. It will create a suction. So I want everyone to feel it. We use that to place it on the baby's head. And if baby's stuck and that baby is in trouble because we used our previous device to measure how the baby's doing, then we may need to help that baby and pull that baby out, okay? Now, we need to learn about vectors and how to pull that baby in the right direction because we can create damage if we don't do it right. So that's where our training as physicians goes into things. So using all that technology allows us to deliver that baby. When you look at that device, there's a bunch of gauges on it. It actually measures the pressure which you pull with, the amount of suction it has, and how hard you're pulling. So lots of different gauges on that stuff you just have to know. And there's a release valve that you use your pinky on, so it's a really convenient device. And I can show you guys really quick, and then as you guys do this. So this is called the Kiwi vacuum. Okay, and a lot of mathematics, a lot of engineering went into this. So this would be baby's head. I put this here. I pump up to the green zone, and then I will pull this, and you'll see it creates a big suction. So, and then you will pull the baby this way, down and then up, and then you'll see there's a lot of gauges. There's a gauge here, and here's my release valve as a pinky, so very convenient. It's how you operate this and create a lot of pressure. So let's pass this around. Be careful if it suctions too much, don't bruise yourselves. There's also some dressings. This one on your left is impregnated. It's a hydrocell with antibiotics and a lot of cool gels that allows for healing much faster for big wounds. After I do a C-section, I will place this. This one is another cool dressing, has silver in it. Silver has antibacterial properties, so we can use that. So taking knowledge of the properties of materials allows us for faster healing. And finally, not everything has to be big tech. There's this device. 2 rings with a plastic sheath in the middle, right? Seems like a simple thing, but when you roll them, you insert them into an opening. Here's my incision that I've made to deliver the baby. If you see on the top there's a uterus that's being exposed, but I want better exposure. So I put this device, this goes inside the abdomen, and then I roll it down. It now creates back pressure, and it gives me an opening to see where I'm going. I can then deliver baby and have my repair without using any other pair of hands. So very simple thing that can go a long way. And this is what you guys have to think about. Simple solutions can go a long way. Nanotechnology, all this beautiful stuff with the iPhone allows us to do bigger, better things. Bottom line is find your passion, decide what you want to do, and follow your dreams. I have enjoyed medicine. I enjoy teaching. I enjoy passing on my knowledge so that you guys every day can also find what you want to do. Let's pretend I have a glass of water here, and I want to make sure that your dreams aren't impossible. Let's say this is a glass, let's see, or better yet, how much do you think this weighs? One thumb, right? Yeah, one thumb. Anyone else? Half a pound. Okay. How about if I told you it depends, and I'll tell you why. If I carry this for a second, no problem. I can do it all day, right? If I carry this for an hour, I'll probably get really tired. If I carry this for a day, my arm may go numb and I will be really hurting, right? So perspectives are sometimes carry into what it is. I tell you guys this because as you worry, as you stress, for those of you juniors in high school right now that are going through a lot of challenging times as you're getting ready for college and thinking about these SATs or these preparatory tests, don't carry that stress every day. Have a means of dissuading that stress because you gotta not let it carry you down. You don't want to go numb and lose that arm. You want to have stress, promote you to do better things, and be able to handle it. So choose your dreams, follow them. Don't think I can't do that. Is how am I going to do that? And that's what will allow you to do what you want. So pleasure talking to you guys. I'll open the floor for any questions if you have any, but keep going through stems. Yes.
Asking this as a parent, but I don't think I am asking this on behalf of my children. At what age did you come to realize that you wanted to do
I think I always knew I wanted to teach. I started with my desire to teach, and I have 3 sisters, and so I played a role in teaching them something, and I always enjoyed it. Was I always the best at it? No. Was I harsh with them? Yes. But I knew I could pass something on, and as soon as you spark someone's interest, that's when so I'd say maybe 7, 8, I knew. Did I know what I wanted to do in medicine? No. It was not till I did college and medical school that I went ahead and really grew and ended up in family medicine and women's health, which I never thought I would do, but my eyes were opened.
We just need the people who have a question talking to the mic so it doesn't get
Oh.
recorded. Anyone else? Question? That's there.
Go ahead.
You talked about CRISPR as a life-changing technology, especially addressing sickle cell anemia. Are there any other applications that you're really excited about in the decades to come?
Any applications that are currently being done? I think CRISPR was used actually in the creation of our vaccines. So vaccines, as we know, as nanotechnology begins to be made. Nanotechnology is literally little machines that can be bound to a cell or a particular cell, and if you can direct them and signal them and attack them, in immunotherapy, you can have a cell recognize a cancer as a foreign invader and target that cell. Chemotherapy today destroys all cells, right? And that's how you get rid of the cancer. But if you can direct it towards a specific cancer, that's what you could do. And through genetics, and CRISPR is probably going to be a big thing because CRISPR is just the machinery that reads your DNA. And so if you can take care of that GPS, you'll get anywhere on the body, and that would be amazing. So,
What type of materials do you need to create all the nanotech and stuff?
Say that again.
To make the nano, what materials do you need?
This is for bigger minds than myself. This is for engineers. Remember, I'm in the clinical field, so I don't know what materials, but it would be materials that are safe and not reactive to the body that can stay there a long time. It'll take a long time to really know what you need. You're probably going to take a vehicle that's already existing and learn to control it with small devices. So sensors. How many of you guys have a phone that tells you how far you've walked? That probably has an EKG function. You guys already have a bunch of sensors. Look, I have my sensor right now, right? I can tell you my heart rate and everything else and alert. So those sensors are going a long way and collecting data that we can use later to apply. And so all these things are creating bigger things. So amazing. Yes. Oh.
What are some of the obstacles you see in the future? Would it be more to do with ethical considerations or regulatory challenges? What would stop something like this?
Great question. So as I'm mentioning all these possibilities, right? Like the field is large. We have to have ethical and legal protections, right? And so, as I told you, healthcare is a big ball of a lot of fields. So if you were a lawyer and working on this stuff to create patents, to protect your ideas, to create the laws that will prevent you from invading into people's privacy, from creating laws that are going to protect people from damage from these materials that may be hazardous, and the ethics of it, discussions of it to create laws for this, yeah, that's going to be a big thing. So we need lots of lawyers, lots of people who deal with ethics, laws, politicians that help us bring that together. So it is going to create a cohort of teams to bring this forth. Great point. I think we have one more question.
Yes. So sickle cell anemia. I've heard that a lesser form makes the person immune to malaria. Is there currently technology that can turn sickle cell anemia into the lesser form to boost immunity for malaria?
You are already thinking ahead, my friend. I love it. So yeah, can you take the ability of something to protect you from others? Why do these things arise, right? Why do diseases arise? They're a means to protect yourself from something, but then they damage your body. And so can you take aspects of something that could be very harmful and help you? Viruses are bad, right? But viruses can be vehicles into the cell that can correct things. So remember Lenmeldi, the thing I was telling you about? It's a virus vehicle. And so we may be able to use that lesser component of sickle cell or parts of what sickle cell does to correct problems in the future. So yes, keep that thought and build on it. And that's what you guys want to see. Where can I step in or where can I correct this? And not, I can't do it. How am I going to do it?
All right, thank you. That concludes our second Q&A session. Now please put your hands together for Jason Glasser. Thank you, Mr. Glasser, for a great talk.
How about now?
All right. Our next speaker is an alum of Saratoga High School and is now creating strides at Intuitive Surgical, a leader in the growing field of microsurgery with robots. Jason Glasser started designing robots in the first robotics program while a sophomore at Saratoga High School, and he never stopped. He holds a bachelor's degree in mechanical engineering from Carnegie Mellon University and a master's degree in mechanical engineering from Johns Hopkins University, and has spent nearly 15 years transforming innovative ideas into reliable tools that expand physicians' power to heal across the globe. Previously, Jason developed 3 generations of the flagship Da Vinci robot, taking surgery beyond the limits of human hand. He is currently a director of hardware engineering for Intuitive Surgical, designing the Ion robot revolutionizing lung cancer diagnosis. Please welcome Jason Glasser.
All right. Hello, everybody. I'm going to talk to you about surgical robots today, the past, present, and future of them. So just a quick disclaimer. I work for a company called Intuitive Surgical. They design and manufacture surgical robots. They had nothing to do with this presentation. It's all my opinions. So, if you don't like them, come to me, not them. All right. So we'll go through what is a surgical robot, and then I will give a brief history of surgery. Dr. Gonzalez can fact check me. And then I'll talk about what's coming next in surgical robotics. All right, so what is a surgical robot? It's essentially a tool that surgeons can use that allows them to reach, see, or manipulate tissue in ways that their traditional tools cannot. And they accomplish that through basically what we call mechatronic systems, which is a fancy term for motors, sensors, and control algorithms, or what you might call a robot. So there's lots of different kinds of surgical robot. We break them down into sort of 3 categories here, depending on what they do. The first big branch is, does it mimic the surgeon's motions, or does it constrain the surgeon's motions? And so if you look at the mimicking the surgeon's motions, there's sort of telesurgery, where the surgeon sits at a console and he or she moves their hands and the robot replicates those motions inside the patient. Or there's a co-manipulator, where the surgeon's right next to the patient using the robot arm, and then the robot arm is mimicking those motions inside the patient. So that you'll see a lot in soft tissue robot surgery. In things like orthopedics, you see a different type called guidance assistance, right? And these are more like if you have a car that has the lane keep assist feature, where as you start to drift out of your lane, the camera see it and it nudges your steering wheel back in the right place. This is more like that, where in orthopedics, you often want to drill in a very specific spot or cut in a very specific spot. And so the robot says, oh, you're getting off course here. Let me nudge you back into the right spot, create some limits for you. So there's those big branches, but then surgery is also not monolithic, right? There's many, many different kinds of surgery where the surgeons have specialized. And why have they specialized? It's because the skills and the tools you need for cardiology are going to be completely different than gynecology or orthopedics, right? And so the needs of those procedures drive the surgeons to specialize. For the same reason, they're driving the robots to specialize as well. The robot might need more reach or be able to apply more force or move faster or have a different imaging technology built into it. So you see sort of this proliferation of robots, surgical robots, based on what specialty they're for and whether they're in one of these three classes. So there's a lot of these procedures being done already. Last year, there were over 2 million robotic surgery procedures performed worldwide, and that number continues to grow exponentially every year. But why do we need surgical robots, right? Aren't surgeons great already? And the short answer is yes, surgeons are great, but I want to contextualize why surgical robotics is coming by giving you a brief history of where surgery has come from, and then I'll talk about where I think it's going. So surgery is kind of weird to me, actually. It's sort of, if you think about it, you're cutting holes in somebody to make them feel better, and that's not necessarily intuitive, right? And so we look back through the historical record and say, when did people first have this idea that I should cut into somebody to make them feel better? And I'm not an archaeologist, but about 7,000 years ago, archaeologists agree this is the first time they find something called trepanation. It's where they drilled holes in people's skull, and they say, we're pretty sure they were trying to make them feel better, not worse, and so we're going to call that the origin of surgery. And then, things don't move very fast in the field for a long time. It takes another 2,000 plus years before we find our first surgical manuscript. So there's a record in Egypt where this guy says, hey, if you're seeing these symptoms, cut here, here, and here, and the person might feel better. It's very basic. It's actually our first record of cancer as well, so it's a very important manuscript. And then, surgery is kind of the same for a very long time until the 1800s when two really important innovations in surgery happen. The first is the advent of anesthesia. So before this, any surgical patient is wide awake and feeling everything, which you can imagine really limits what you can do. So basically, if you don't pass out on your own, you're awake for your surgery. The other thing that's going on is we haven't figured out germ theory yet. They don't know about bacteria or viruses or anything like that. And so it was common practice to practice a surgery on a cadaver and then go without washing your hands or your tools and then go do that surgery on your patient, right? And so you can imagine infection rates are incredibly high. You're actually more likely to die of surgery than live through surgery at this point. But these two inventions in the 1800s changed surgery, right? Now it's starting to become what you and I would recognize as a medical practice where people are surviving, the techniques are able to become much more complex, the things they're able to treat become much more complex. So this is huge. But there's still a problem, right? And the problem is when you go to do these surgeries, they're doing what we call open surgery. And in order to do the surgery, you need to be able to see what you're working on, and you need to be able to get your hands and your tools in there. So you're cutting these big holes in people to do these surgeries. And it turns out you have a long recovery time when you have a big hole cut in you. There's lots of blood loss. And so often people are spending weeks in the hospital recovering from the incisions, even though whatever the thing that brought them in has resolved. So big cost to the patients here. And so in 1910, around then, people get this idea for laparoscopic surgery. So we've got cameras now. What if we stuck a camera inside somebody and put little holes in and try to do the surgery inside somebody? And this is huge for patients. Like, so this is the birth of minimally invasive surgery. You're now not recovering from these massive holes. Your blood loss is way lower, and recovery times are much faster. So this is great. The only problem is it's really hard, right? Have you ever seen those sticks that people use to pick up garbage, like those little claw machines? Imagine you're trying to do surgery inside of somebody with two of those while your best friend holds a camera and you say, can you point it over there? No, the other way. And they're like shaking, trying to look at the image too. And you're trying to sew somebody's liver back together while that's happening. People are amazing. Like a skilled laparoscopic surgeon can do absolutely amazing stuff this way. It is mind-blowing to see what these people can do laparoscopically, but it's really, really hard and it takes a really long time to get that good. And so that limits how many people can have this type of minimally invasive surgery. It limits who can do it. And so around the 1980s, 1990s, people started thinking, you know who's really good at being steady and making things small and get into places? Robots. What if we put a robot in the loop and had the robot hold the camera or even hold the tools? And that's where sort of the birth of robotic surgery comes in, so robotic assisted surgery. And in the year 2000, this Da Vinci robot gets FDA clearance. It's the first soft tissue robot to do that. And people start doing laparoscopic surgery with a robot in the loop, where the surgeon is sitting at a console, moving a robotic arm, and then another robotic arm is mimicking those motions. They get their wrists back, they get 3D video inside the patients, and it's game-changing in terms of not necessarily the outcomes that a skilled laparoscopic surgeon can do, but being able to get less skilled surgeons able to get the same sort of results. And that's been going on for about 24 years. This slide's from a while ago, so the last time I did it in 2020, it was 1.2, 2023, 2 million. So that's really the need that these robots are filling. And then you say, okay, job done, mischief managed, is surgery great now? And I think the answer is no. There's still a ton of work to do, and I'll talk about 4 trends that I think are coming. So quick disclaimer, my next slide does have a surgical image on it. If you don't like seeing that, close your eyes. I'll tell you when I'm on the next slide. It's the least graphic one I could find, but if you don't like it, just close your eyes for a second. All right, so it wouldn't be a presentation about what's coming next in technology if I didn't use the words AI. So there's 2 trends here, augmented reality and AI, that I think are going to have a huge impact on surgery. On the left here, what you're seeing is an image where the surgeon is watching the surgery through a viewer. They've injected a dye that's invisible to our eyes into the patient, and then the robot is able to image that, retouch the image, and show where the blood vessels are. So now the surgeon can see really clearly, I don't want to cut here because this is where the blood vessel is, whereas in the untouched up image here, it's very difficult for you or I to see that, and it takes a very skilled surgeon to identify those blood vessels. Up on the right here, you have an image of the lung that's been rebuilt from a CT scan. And the surgeon has identified a lesion that they think might be cancer that they want to go check out. And the robot has said, okay, well, here's the path we think you should take through the lung to get to that lesion. And then during the procedure, it'll actually give you sort of turn-by-turn guidance like you're following Google Maps rather than having to remember, wait, am I turning left at this branch or right? And it allows you to get to that lesion much, much more reliably. And then in the bottom, you're getting into diagnosis. So right now we have radiologists who look at medical images and say, okay, that's something of interest, that I think is cancer, that might be brain damage. But we're, with AI, able to train image recognition software to say, you know what, we think that AI can now find it, and they're starting to see better results from the AI than from radiologists who are trained. So very cool stuff happening there. The next thing is getting even less invasive. So we've gone from these big, 30 centimeter slits to 1 centimeter slits in people, but that's still cutting into people, right? And so there's technology working on up in the left here. You have on the tip of somebody's finger there, that little microbot that can be steered by electromagnets outside the body. They're trying to use that to do eye surgery and actually go in and do surgery on the eye with something that's that small. On the bottom left here, you're seeing a very small, very flexible robotic manipulator that can go in through some of the natural orifices, that don't have to cut any holes. And then this system on the right is for doing microsurgery, actually attaching things like blood vessels back together or even nerves in some cases. So we've done a lot to make surgery less invasive. I think there's even more to do there. Third trend, global access. So I said there were 2 million surgeries done last year by robotically. There were over 300 million surgeries done worldwide. So that's still a small percentage of surgery. Most of those 2 million were in wealthy nations like the US or some of the European countries, Japan, China, Korea. But we're starting to see those go to other countries as well. People in those countries developing their own solutions that fit their own healthcare systems, or some of the American companies and European companies finding ways to reach those patients as well. So I think you'll see more and more patients receiving this state-of-the-art care, not just in the United States. In fact, even on the space station. So a couple weeks ago, the first robotic surgery was done in space, not on a person, but on, it looks like a rubber band. But this is the idea that because you're now doing telesurgery, if you can figure out latency, people on the ground can do surgery on people on the space station or Mars or wherever. So that's really exciting. And then the last trend is more specialties, right? So I talked about surgery coming into different specialties. There's ones where maybe the value proposition wasn't as strong, but now because the technology has advanced and come down in price. So you can now see coming into dentistry on the left. So this robot is FDA approved for doing dental implants and making sure that if you have osteoporotic bone or a very thin jawline, they can still get the implant in without pain. And even on the right here, this is maybe not quite surgery, but this is an eyelash extension robot that's under development. So taking that technology into cosmetics and beauty, which is kind of cool. So I think there's way more to do in the field. I think it's going to be really exciting and change a lot over the next few years, and there's plenty of opportunity for all of you to get involved. I think that's my last slide. There we go. All right, questions for me? Sure. Oh, we got to get the microphone.
These type of surgeries, how it is possible to get this to the common people? Does this covered by insurance? I think this applies to Dr. Gonzalez as well.
Yeah. So yes, in the U.S., for a lot of these surgeries, they are covered by insurance. If you need a prostatectomy, the majority of prostatectomies are now done using this technology. It's considered the standard of care, which means the physicians get reimbursed from insurance for these procedures. Yeah, in the back.
I'm curious, on your last slide, you showed a robot doing eye surgery. What type of eye surgery?
Oh, it was not eye surgery, it was eyelash extension. So they were actually gluing on false eyelashes to the person's eye so that they had fuller, more beautiful eyelashes, I guess.
Okay, okay, thank you.
If something goes wrong with a surgery, is it the doctor's fault or the robot's fault?
Oh, that is a great question. So a lot of my job is around making sure that the robot is safe and effective. And so we spend a lot of time building in safety systems so that the robot detects if it has a problem and then does what we call transitioning to a safe state. And then it's sort of the robot's job to get out of the way at that point. And so we make it so you can clear it, and then the surgeon can go in and continue the procedure if the robot fails. So the robot is never going to go crazy and move on its own. That's very carefully engineered into it. But it is still a very complex piece of technology. If it does encounter a problem, we want to make sure that the surgeon is the expert in surgery and that we get out of their way and let them make sure that patient receives the best care possible.
This is pretty fascinating, especially in the developing countries and stuff. The expertise may not be there. Are there thoughts about autonomous surgeries for less risky ones like cataracts and stuff?
I'm sorry.
Autonomous, without a doctor having to be present.
Oh, autonomous. Yeah. There is, in academic settings, research into what can be automated and what can't. I think that's a long way off. There's a lot of barriers to that. both technologically and society, right? You know, we have a lot of faith in our medical professionals. I think it'll be a long time before we get to that level of faith in our systems, even if they start to show that capability. Yeah.
You mentioned that these robots are only available in richer nations. Is that because they're expensive to use, or are they just expensive to make?
Oh, that's an interesting question. So they're expensive to use, right? So because of the need for sterility, there are parts of this robot that get thrown out at the end of, they're maybe reused for 5 or 10 procedures. And because they have complex technology in them, that it's hard to get the price down. And so that does mean that they are more expensive ways of doing the procedure than traditional laparoscopic would be. However, if you count in, recovery times and things like that, the math works out. But that means that for healthcare systems that can't put in the upfront cost, it can be challenging. But there's lots of work being done to bring those costs down. Good question. Got 1 minute left. All right.
It's a quick question. You said if robot detect the risk, then human doctor can interrupt, right?
Yep.
Then whose responsibility if something goes wrong?
Yeah, I think that's a question for the lawyers. It's a little bit like asking if your car stalls out and you get stranded, is it the car's fault or the driver's fault? I think you say, well, the car malfunctioned, but you don't, this is not a good analogy. What do I want to say here? Yeah. Yeah. I think it really depends on what happens. So it's a tool, and if you're using a tool in your workshop and you misuse it and you do harm to yourself, whose fault is that? Well, did the manufacturer not put in the right safety systems to prevent you? That's the conversation for the lawyers to figure out. Yeah. Wow. All right.
That concludes our second Q&A section. Please give Mr. Glasser another warm round of applause. Thanks so much.
All right, everyone, we will now be taking a short break. Please help yourself to snacks on the table on the side of the room and be mindful of the timer on the screen. We will reconvene in 10 minutes to welcome a student robotics team from Saratoga High School.
Everyone, please take your seats. Our next guest presentation is from a student robotics team from Saratoga High School, a 6165 MSET Cuttlefish from the First Tech Challenge Robotics Competition. And founded in 2012, the MSET Cuttlefish have won various awards for robotics games and their contributions to the community. They have received the Inspire Award, which is the highest ranked award in the competition for the past 2 years at the World Championships. And they're proudest of having held the annual pumpkin smashing event at Halloween for 2 years now and are excited to present their robot to you today. Please welcome the MSET Cuttlefish.
If you guys would like to come closer to get a better view, please do, but make sure you guys don't step on the mat to avoid injuries.
Thank you so much for that introduction. Well, hi everyone, my name is Manlin. I'm a member of team 6165 MSET Cuttlefish.
Hi, my name is Ethan, and I'm also a member of 6165 MSET Cuttlefish.
Before we jump right into the robot demo, we're going to give a brief overview about MSET, which is the organization we're a part of at the high school, and also FIRST Robotics. Okay, the clicker's not working, but we'll go manual. Okay, so what is FIRST? Well, it's a competitive robotics league with over 3,000 global teams across the world, and it encompasses 3 kind of leagues based on your age level, which is FLL, FTC, and FRC. So while it's also a robotics challenge, another important part of FIRST is the outreach that you do to local communities. So this can include business and outreach, which means that everyone who's part of a robotics team in FIRST is also a well-rounded individual individual who knows how to work on a team. And one of our main adages is the gracious professionalism, which means even though you're a part of a team, you are also helping others and making sure that you're being gracious as well as being professional. Okay, so what the organization that we're a part of is Saratoga High School's MSET Robotics, and this is a robotics team with over 4 specific robotics teams in FRC and 3 in FTC as well. So we have been around since 2012. One of our speakers today, Dr. Jason Glasser, he has actually been part of the MSET Fish team over 20 years ago, so that's pretty cool. Nice to have an alum here.
Okay, so the first of the 3 programs is the first LEGO League, and that is targeted for elementary and middle schoolers. And there they essentially have pre-built parts that allow them to design robots and start to basically get introduced to robotics with LEGO and pre-built parts. The second one is FTC, and this is the one that we take part in. And here you can see that you can start to, these robots are a lot bigger, and you can start to design your own parts, and you essentially are allowed to make custom parts. Like you can see on that robot, you're allowed to design your own plates. You can 3D print your parts, whereas before you could only use Lego parts. And then FRC is on an even much larger scale, where you have robots that are like this large, and you're essentially trying to design robots that have a lot more complicated mechanisms, as you can see.
So something really important about being on a robotics team that I'd like to point out is even though there are engineering classes at every single school, you can go there and learn engineering concepts, and you can get good at them as well. But what really challenges your understanding is being able to actually innovate and design parts of a robot that shows that you have really understood those engineering concepts and are able to put them into an act by building the robot. So while this might come as granted, we're part of Saratoga, everyone is probably going to go into STEM at some point in their life. But in areas where the majority of people are underrepresented in STEM, they might be part of an underrepresented demographic, or they might just be under-resourced students, FIRST can really change their lives. So for example, we've been working with 6 Oakland teams for the last 2 years, and they're mostly comprised of seniors and juniors who are deciding where they are going to go in the next chapter of their lives. And something that we've heard from many of these students is, beforehand, they hadn't considered engineering as a profession, but after doing robotics, they are now going to declare themselves majors, engineering majors at their universities. And we think that is awesome. Robotics is a great way to not only grow your skills, but also spread love of engineering to many communities. And this is why we're super proud to be part of a robotics team. Okay, so we are going to move straight into the robot demo. As mentioned, if you would like to get closer, please come ahead and sit around 1 meter away from the tiles. If you're a teen, especially, please check out these robots. And yeah, Ethan here is going to begin driving the robot. Just a shout out for Ethan, he actually he drove the world record solo for this year's competition just a couple weeks ago. So. As we watch Ethan drive, if you have any questions about a specific part of the robot, we have prepared an entire presentation deck for you guys. So. module that I'd specifically like to highlight is the deposit mechanism. So as you can see, what Ethan is doing is picking up the robot through the intake, which is what we call the surgical tubing, that is essentially sweeps the pixels into the robot, and then when it goes through the transfer mechanism, it goes, oh, that happens sometimes. This is called DCing, and it happens during competitions at the worst moment possible. So well, this is a great time to go over the deposit. So as you can see, it grips 2 pixels using the claw mechanism, and then one of our original designs for the robot was just, you can see it just holds 1 pixel at this point, and it's holding 2 pixels kind of on top of each other. And while this was a great strategy for getting pixels onto the board fast, it didn't allow us to have the same modicum of control that you can see we have here. We can place 2 pixels wherever we want onto the backdrop, and this is why we switched to a kind of parallel pixel mechanism. This is the final version of our deposit. And something that is really cool about this one is that you can see how the slides are mounted onto the deposit so that you can actually slide horizontally. And this allows you to score sideways. Ethan, are you having any luck with the robot? Great.
So this is our hand mechanism. And essentially there's a bonus period in the game where you're allowed to hang on like a bar that goes across, and you're allowed to suspend in the air. So that right there would be our hang mechanism, and it would pull onto a bar, and like basically do a pull-up. And then here we have our drone shooter, where you also are trying to shoot a plane into a specific distance. And I'll just demonstrate it to the side over here. And yeah, that's pretty much all parts of robot. Do you guys have any questions about like its functionality, how we designed it, or any part of the robot? So we started designing this back in September when the game was released. So like, because each year they have a different challenge, so we have to design a different robot for it. So September, yeah, last year, 2013. I mean, the budget, like, I think it's around 15K, but we probably spent like 4K, I'm estimating, on this robot. There's actually a lot of parts on our robot that use 3D prints. Like you can see these things that hold the surgical tubing. These are 3D printed. This camera mount is 3D printed because it fits the shape of the camera. This wall right here in the front of the robot is 3D printed. Almost every part of the robot has 3D print on it because it just allows you to make something custom that fits the shape and needs of designing. Yes?
So you're a body of students building something cool like this, but I'm sure you have a teacher or a coach guiding you through this process. But what are some of the prerequisites that a high schooler, let's say a 9th grader, might need to get into something like this? Or is it open for anyone, to anyone's curiosity?
Our MSED program is open for anyone. We actually have a rookie team system. So we have rookie teams that feed into our cuttlefish team, this one. And essentially, through their first year, they are using sort of pre-built parts. Like they might use a channel that's already pre-built. And they essentially learn how to design robots, like essential parts like a drivetrain or the scoring mechanism or like a claw. And after that, they can start to learn how to design custom parts for that. So instead of using just like maybe 2 metal sticks, you start designing the 3D print that is made to like the right, like I guess, has the right feature you want for like your claw mechanism. So essentially, I think I didn't have any experience when I joined MSET. I had really little. So I think I just gained my experience from just learning to build with it, and then I was able to learn how to design it after I got used to it.
So when you're designing your robot, like what do you start with first? Like do you start with the drivetrain first or like the intake or?
Okay, so when we design a robot, we actually start with like a high-level overview because if you just start with like the drivetrain, you can't really like figure out how is your like slides going to fit on that drivetrain. So you kind of have to think. You have to have like a spatial awareness of where each part of the robot is going to be before you do that. And we kind of decided at the very beginning of the season, like within the first week of brainstorming, we had a rough idea like, oh, we want the depositing mechanism on the back of our robot, and we want the intaking on the front. And then as we design it, we work with each other to make sure. Sorry, let me go back. Each of us design our own module on the robot. So like I designed the drivetrain. Jared, for example, one of our team members designed the intake, and I worked with Jared to figure out like the specifications of how it would fit together as we designed it.
Where did you guys get the inspiration for the robot from?
There's some like general trends for inspiration, like surgical tubing is like a commonly used thing that you use year to year. Like there's a lot of mechanisms that can easily like be picked. There's a lot of elements like this one, for example, can be like pretty easily picked up. But we had like 2 years ago a cube and a ball, and those could also be picked up by surgical tubing because it's just flexible. And so the inspiration for like general designs comes from just year-to-year experience and just seeing what works and what doesn't. So yeah.
It's also really cool because, as we mentioned, innovation is something that happens like not just before the season when you're designing the robot, but also during it as well. So you're not just like copying, because robotics is very like individual. Okay, that when you go into the workplace, you don't design something that looks exactly like this because it's based on a game, right?
Like she's just
So
doing
much of the
manually,
innovation
so.
just comes from. Much of the innovation comes from students just like you. So one example is last year we had dead wheel odometry helps you localize the robot on the field during autonomous, which basically like tells you where the robot is. And last year we designed a module that allowed it to retract, so go out and then go back in. And then what was really cool is that after we debuted our robot, our first qualifier, a lot of the teams started taking inspiration from the retractable dead wheel odometry. And yeah, that's kind of how trends spread throughout FIRST. It's really collaborative effort and part of why we call ourselves gracious professionals, because we spread our ideas and also help other teams achieve, things just like we do.
How do you guys use Onshape to, like, with the drafting process?
Could you repeat that question?
How do you guys use Onshape for the drafting process? Or do you guys use Onshape?
We use SolidWorks. Did you mean like the rendering process, or?
Yeah, like the CADing?
Oh, for CADing, to design our robot, we use SolidWorks, but to render and like get these images, we use Fusion 360. We upload our robot to that program.
Okay, I had a question. Sorry if you already went over this, but what's like the ultimate goal of the robotics competition? Like to put the most amount of the hexagons on the
It depends.
thing?
Like, what's the primary goal in the game?
Yeah.
So in this game, you're supposed to take these pixels here, and you're supposed to put them on the backdrop. And you can get points from just putting them on there, but you can also get points from getting to each of these lines here. So each line is 10 points. And scoring the pixels here is 3 each. And if you put like 3 pixels together like this, you get an extra 10. But if it touches like another yellow, then it doesn't count. So you have to make sure you have isolated colors. And those can get you extra bonus points. So yeah.
Yeah, just to clarify, this is like a very downsized version of the actual field. The actual field is quite a bit bigger than this, and there's a massive truss in the middle. So the game changes every single year, which is why you need to design a new robot every single year. But yeah, this is just a preview of what the robot game looks like.
Oh yeah, should we take a break? You want to announce a 5-minute break for you to clean up? And then...
Sure.
We can take a quick 5-minute break while we wait for them to clean up. Thank you very much for your enlightening presentation, Cuttlefish.
Thank you very much. Yeah, but it's a special because one and us.
Yeah.
Yeah.
Yeah, you are like that. That's the journey. We're going backwards right now. That's also good.
Well, I don't know. I mean, I would have thought that. Oh, well, no. Okay, so this. Yeah, okay, this is probably forward. Yeah.
I'm going to switch back to a timer.
Last year was got to choose which prize you want. Well, whoever got the first ticket choice. But also a good idea. Definitely discuss. Even the ones that are the bad ones. I think what we should announce is, hey, remember, we're still doing the raffle after, so hold on to your ticket. Arthur, please come here. Okay, so you got the clicker that works, right?
I do.
This is, but it probably happens all the time. I checked both of them yesterday, they both work. And are fully charged though. I don't know.
Hello, everyone. I just wanted to remind everyone to make sure you have your raffle tickets. We'll be drawing for the prizes at the end of the event following our final speaker.
Yeah, so the issue is that I'm actually giving a talk right now, and so I'll be busy till 3, but then I really should kind of, yeah, there's some work that I need to do this afternoon. Okay? So tomorrow afternoon sounds great. Okay? Okay, talk to you then. Bye.
Are we ready?
Yeah, I'm ready. Hello? I'm good.
All right, everybody. Thank you for your patience. If everybody could go get back to their seat now, we're going to begin the final speaker and then go into raffle prizes to conclude out the event.
Are we ready?
Yeah.
Is the recording going? Are you recording?
Our final speaker is Thomas Casavant, who has formerly worked at Lockheed Martin Security, an aerospace company, and currently teaches AP Physics for Saratoga High School's Physics Department. Thomas's undergraduate studies in physics and math at St. Michael's College in Winooski, Vermont, and earned a master's in physics at the University of Wisconsin studying plasma physics. Thomas bounced between the defense industry and high tech for 30 years on a thread of optics. 10 years ago, Thomas decided to step off the carousel and wed his two passions of science and teaching young adults by becoming a high school science teacher. This is Mr. Casavant's first year at Saratoga High School, and he says, with any luck, not his last.
Please welcome Thomas Casavant.
Thank you. Yeah, so it is looking like it's going to go that way, and I should be here next year, so I'm looking forward to that. There's a bunch of my students in the audience, and really this is directed at them and some of the other young adults who are out there. Yeah, I spent 30 years in defense and semiconductor, and the mayor is probably gone. Yeah, so I developed I helped develop metrology for the semiconductor industry, and that's what I did for the semiconductor industry. So it was kind of a line of optics through my career, both in defense and semiconductor. Okay, but being an old guy, I'm kind of toward the end of my career. I had two choices: either get off my lawn or avuncular advice. So I went for avuncular advice. Okay. Wrong way. Okay. So a couple of life lessons that I've come to. Okay, and this is really kind of tying into where a lot of my students are right now, because I'm writing recommendations for students who are going off to do some, or trying to do summer research, and it's a really wonderful opportunity, and this is kind of directed at them to a large extent. Okay, so when I look back at my life, and I'm old enough to kind of do that, the things that really matter to me are relationships and accomplishments. Okay, and so when we consider relation, and I talked to my brother about that. I was telling my brother that I was going to use it. Wow, that's kind of heavy. You should probably have some jokes. So here's the joke, and that is, how can you tell where flamingos live? Because of the plastic pink French Canadians on their lawn. Okay, you'd have to be French Canadian to understand what that means. But anyway, so that's kind of where I grew up. Anyway, so relationship advice. So promote relationships, high quality relationships, and demote negative relationships. Okay, so then what do you mean by a negative relationship? Okay, don't negative relationships who don't support your goals. Okay, waste your time is especially one of them. Okay, because life is made up of time, and if somebody's wasting your time, that's not pushing you in the direction you want to. And also, relationships deemed not worth the investment. But that's kind of a weird one, because quite frankly, the first job I ever had was actually in nuclear weapons effects research, which is a software job because you don't do a lot of hardware nuclear weapons effects, right? So we did a lot of modeling, and I was terrible when I started. I was really bad. But my boss actually saw something in me, and he worked with me, and I actually became very good. And that was one of the major accomplishments in my life, was associated with that. But deciding what's worth your investment is an important choice, though, where you're going to spend your time. Okay? High quality relationships are a little more subjective. For me, what this means is we have common interests. Imagination is really important, that you have a broad vision on things, and you're interesting because you can talk about different things, and then the last thing is kindness. And that, for instance, the boss that I had at my first job was a kind person. So that was very important to me. And I'm blessed with a number of good friends. It's one of my great joys in life. Okay, so relationship challenges. No thinking person will agree on everything. And so, avoid contentious topics. And often people are the consequences of their histories, and you have to be somewhat tolerant of that. I have people who have pretty wacky ideas, but they got there through it. I have a friend who, they're very different people. I have a friend who ran away from the Japanese, who were dropping bombs on them on in China in World War II, and so he has a very interesting view on a lot of things because of that. Because it was just his history. So you got to be kind of understanding of people, because not everybody came from the same place you did. And so you need to understand where they come from and how they get. But again, it comes to the quality of the person, not necessarily how they got there. right? Okay. Dimensions of friendship, compatibility and time, okay? So you got to be compatible with peace. And this is kind of an interesting thing. That is one of my good golf buddies, and we're going to get together this summer, was in Wisconsin, and he was a very good friend of mine. Turns out he's a better friend of my son's now because he was at Wisconsin. That's where we met. And my son went to Wisconsin for graduate school, and he ended up spending so much time with them that they became very good friends. And so it's kind of interesting. Okay, accomplishments. Accomplishments happen when preparation meets opportunity. Okay, so remember, opportunity knocks only once. Temptation leans on the doorbell, okay? So it's hard to get around that. So this goes back to your friends, right? And so if you've got friends who are, providing that temptation, you should probably think about reevaluating that relationship, because if they're tempting you from achieving your goals, that's important, and that's going to help define your future, okay? Or build your future, okay? Take advantage of your opportunities. So a great example of that turns out to be the son who's the friend of my friend. So for instance, when he graduated from high school, I called another friend, a different friend. I knew that my son wanted to be in bioengineering. And so I have a friend who happened to be a VP of a bioengineering firm, Caliper. I don't know if anybody's ever heard of it. They're gone now. So I called him and I said, hey, do you have anything my son can do? And she said, no, we hire college grads as interns, not high school students, right? But it turns out that she called me a couple of weeks later and said, there's something he could do, because there was this new technology, this new capability they were developing, and there were two ways to do it. And one was exciting new science, and everybody wanted to do that, right? And then there was another grungy way that, is just turning the crank that everybody's been doing for 20 years, and nobody wanted to do that because it was really boring, right? So they said, stick the high school student on it, no problem, right? Because this guy, he's willing to do this, exciting for him. He hasn't been doing it for 20 years, or 10 years. And so he did that, and he just turned the crank, and he kept on doing the work until the exciting technique ran into a roadblock that they couldn't get past. And all of a sudden, this high school student is standing in front of a room full of PhDs who needed his knowledge. So that was an example where opportunity is where, an accomplishment is where opportunity met preparation. So anyway, you never know where your road will take you, and it could be the road to your accomplishment, okay? And so that's my son. Oops. That's my son, and that's the device. So yeah, he's doing biomedical research, biomedical engineering now, and this collects blood from your arm. Both of these speakers talked about advancements in biomedical engineering, and this is another one. Okay, so this device can collect 200 microliters of liquid blood at home. You drop it in an envelope and you mail it in. Okay, so you essentially there's no phlebotomist, don't have to go into the office. You can be stationed anywhere in the world. You just mail it in, and and do the tests, any test that can be. So this all came as a sequence. This was a road for him that started in a high school, very much like the research that some of my students are embarking on. Okay, so take it seriously, because these are great opportunities, and it could lead somewhere. Okay. Regrets, unkindness, and squandered opportunities. Not all opportunities will pay off. But my advice is ask for guidance, collaborate, and go all in. That's all I have to say. Very short, sweet.
Thank you, Mr. Casavant, for the great talk. He will now be taking questions from the audience. Please raise your hand if you have questions, and a member will come to you with a microphone. Please limit your questions to 2 per person, and be mindful of the timer shown on screen. Thank you.
Yeah.
Yeah, so thank you for the talk, by the way. Very inspirational life lessons from you.
Thanks.
Yeah, I noticed that in your bio, you mentioned that you have done optics for Lockheed Martin. Could
Yeah.
you talk more about what that entails?
For Lockheed Martin? Actually, no. I can talk about the optics I did at Mission Research, but I kind of can't talk about Lockheed Martin. Let me see. Is there something I can talk about? Yeah, there's various optics things that I did that I can talk about. I mean, it was the Mars lander. I actually reoriented the antennas to optimize the signal return, because when they landed it, they didn't know what orientation it was going to be, that it was going to come down, and they wanted to optimize the potential signal back to the United States, and they had configured the satellites wrongly, and so I reoriented the satellites, the antenna, the dishes. So that was one thing that I did. And so, I did analyses to show how the orientation would affect the link budget. And so, those are some things that I did. Yeah. Sure.
Hi, thank you. I agree that was very inspirational.
Thank you.
I'm actually curious about the device your son was involved with. Like, where was the blood drawn, and how did...
On your arm.
Oh.
Yeah, let's see. It's pretty cool. I was just, a buddy of mine was telling me that they just sold their millionth device. So that's kind of cool. I don't think they're in the red yet, though. I don't think they're in the black yet, though. I think they're still in the red, which means they're living on borrowed money.
But you said it started in high school. Can you elaborate?
Oh, no, it started, so that's the device. It started on graduation. I called a friend of mine, and, she was a VP at a biotech industry. And so, I knew that he wanted to go into biotech, so I asked her if he could get a job there. That was it. But it was after he graduated. He graduated from Monte Vista in 2005. Yeah, just up the street.
Hi, Mr. Casavant.
Yeah.
I'm wondering, what inspired you to work for Lockheed Martin?
What inspired me to work for Lockheed Martin? The job sounded interesting. Okay, and the types of things that they were doing, and it's I can't really talk about it a lot, but it was very interesting, compelling work, and I had some opportunity, and those were one of my major accomplishments was at Lockheed Martin, but again, I can't really talk about that. So, sorry about that. The nature of the work, and actually, I had a friend there too, and one of the brightest people I know, and so the opportunity to work with him was pretty compelling too. Yeah.
What was your favorite part about working at Lockheed Martin?
Again, it was a very different project. Okay, so we were kind of stretched in different ways. We were trying to accomplish something which was, how shall we say, difficult. And so accomplishing that, and we actually did accomplish that, and we ended up, succeeding. But it's really hard to talk about this kind of stuff. But it was a very challenging project, and and how to approach something like that seemed impossible is it's kind of compelling. Yeah.
I just have a quick question. I wanted to know if you had any prior experience in the classroom.
Well, when I was in graduate school, yeah.
With high school, what inspired you to decide
Oh, yeah,
to
that's a
come
great
back to
question.
school?
So my younger son was very involved in science fairs. And so when he was doing that, I helped out, and maybe a little too much, but still. But I really loved working with the kids, and I ended up going with him to the international science fairs in Albuquerque and Atlanta. And so I ended up kind of meeting a lot of the kids who were involved in science fairs. And it was wonderful. I mean, some of the kids that you'd meet, I mean, they just had these big ideas, and they really just profound research, and it was just wonderful working with them. And so I wanted more of that, and this is a really fun age too, because it's kind of and as they get older, you're doing more and more polishing, but it just changes. They've got enough of a background so they can be interesting, but you can still make a pretty big pretty big impact. So it's kind of a fun compromise.
This concludes our third and final Q&A section. Please put your hands together for Thomas Casavant.
Thank you.
All right, everyone. We have come to the end of SED Talks. Before we conclude the speaker section of this event, we will draw some door prizes. All right, so here are our prizes right here. If your number is called, please come up to the front and choose out of any of these one that you would like. All right, where is the box? Right there. All right. All right, does everybody have their ticket stubs? All right. All right, our first winner. Here, hold this. All right, our first winner is number 241342. That is 241342. All right, we will move to the next one. This says key. All right, our second winner, 241335. All right. Okay, this one I can feel. All right, 241311. All right. Yeah. All right, all right.
So many of them are keep this coupon.
I think they're all of them are.
No, but the one that you had is an actual ticket.
Okay, well. 41311. All right, congratulations, dude. You got Lego flowers, you got these kits, you got Arduino somewhere. Yep. All right. Our second winner, 241375. That is 241375. All right, keep giving me the tickets. All right. Yeah. All right. Next we have 241333. All right. Our next winner, 241328. 241328. Now we got 241344. All right. Now we have 241364. Me neither. Now we have 241360. All right. Two four one three one seven. That is 241317. All right. Now we have 241329. 241329. All right, all right. We have 241341. 241341. All right. 241316. Yeah. Everybody's gonna win. Yeah. Yeah, I know. 241359. 241359. All right.
Well, I think it's a robotics.
All right, give me the next one. Nope. Now we have 241363. Thank you. Arduino, I don't. It should be outside of the box if there is one. There might be. Now we have 241338.
I think we have more prizes.
Now we got 241345. All right. 241353. Two four one three four three. 241343. Yes? No. Maybe? All right. Let's move on to the next one. 241340. All right, all the kids are winning. That's good. All right, 241352. All right. Okay, we still got it. Copious now. 241324. Yeah. 241351. Hey. 241356. All right. 241357. 241332. 241332. All right. Oh. All right, 241346. 241346. I think I can stop saying 241 now. All right, 241347. All right. 347. All right. Do you know who? All right, I guess. All right, and our final prize, 241312. Nobody. All right. Oh. All right, everyone. Thank you so much for coming to our 2024 SED Talks Engineering Our Future. We thank you so much for spending your time here, and we hope you got something out of it. So.